I don't think we can afford to fail. I don't think failure should be an option.
No, failure has to be part of the equation. You can't have stunning science without failure.
I think the people who have success without having failure don't appreciate it nearly as much as those of us that have lived through the failures.
The laboratory doesn't seem to acknowledge the failed missions, have kind of disappeared.
It's interesting when there is a loss, people who suddenly go away, who don't want to be associated with the failure or who don't want to set the record straight. We want to bury our losses.
I think that it's the pain we can't accept. I think it's the personal anguish. It's the damage to the reputation. That fear has kept us from being even bolder than we have been, although we've been very bold.
We hurt ourselves by describing the process in terms of winners and losers. You don't know how close you are to the edge. They ought to put the successes and the failures about an eighth of an inch apart.
So we stumbled, but let's go back and see what we can learn from that and try it again.
The lab's kind of a neat place to work because it really rewards energetic, smart people. You have people in the lab that have been working here a few years and they talk about, they ask, how do you advance? There's two keys to success at the lab, really only two: credibility and visibility. Sometimes easily gotten, certainly easily lost. Lab's nestled in these hills. It's pretty. It's a big place, a lot of walking. And you get to use these cool badges.
In the late 1990s, NASA's Jet Propulsion Laboratory was on the verge of a new era of exploring the solar system and beyond. Just ahead were 6 new missions, slated for launch in just 6 months, an unprecedented achievement. There were 2 new spacecraft to target comets. One would test a new propulsion method that sounded right out of an episode of Star Trek, while the second mission would be capturing particles from a comet and bringing them back to Earth, something never before done. A space telescope would search for the birth of galaxies. For our own planet, there was a satellite to measure wind speeds across the oceans. And for Mars, there were 2 new missions. The Red Planet became a major destination following the discovery of a Martian rock that some believed contained fossilized microbial life.
Something really, really huge that's going to be taking place over the next 10 years as we send many missions to the Red Planet. And usually one of the most asked questions regarding Mars is there life on Mars? I think there is life out there somewhere in the universe. I don't believe that we can be the only beings in the universe. So I definitely think there's somebody out there watching.
These new missions were signs of how far Director Ed Stone had steered JPL in a new direction. one that emphasized smaller, less expensive, but more numerous missions.
I had come to believe that we had done the major global exploration missions, and we really needed to move on to a new frontier. And the question is, what was that frontier going to be?
The new frontier had a name: faster, better, cheaper. It required embracing aerospace companies as partners and giving work over to them. And agency officials were to be viewed as customers to be satisfied. The new watchword was, make a deal and stick to it.
If we're going to continue exploring the solar system, our engineering challenge, our science challenge, is to find ways to do that at lower cost.
The changes underway also included staff reductions, even as missions were going out the door to industry that was hungry for work following the end of the Cold War.
We agreed to reduce the size of the staff at JPL by 1,000 over a several-year period. Well, when that was announced, it was a bombshell. The laboratory had never voluntarily reduced its staff.
I'd like to hear from you on what are you concerned about? What are you worried about? What are you fearing at this time?
It was very difficult to explain or justify to the employees who were concerned about their job, and said, look, why are you doing this? You don't have to do this. My budget hasn't been cut. Why me?
And one of my concerns is that there is
It colored everything we tried to do. It was a grinding downsizing, you know. Every year you'd ratchet down a little more, a little more, a little more.
But back in the back there?
What should I be doing? Where should I be going for careers? Things like that. Are we going to build spacecraft, or is that industry? Where to go and what to look for in the future is real confusion. I'm not sure where to go with it.
Yeah, well, you might ask, what does our customer in Washington expect of us, right?
And from my level, I have the slightest idea of that.
Faster, better, cheaper.
Really comes back to the basic point, though, that JPL, the reason there is a JPL, the reason there is a federally funded research and development center for NASA is to do things nobody else can do. And so we have to always keep in mind that is really the reason we're here. And if industry can do it, then in fact it's much less appropriate for us to continue to do it. So we have to find a way to always move forward. But we are certainly not in an era where we can say this is ours and therefore we get to do it. In fact, we're being encouraged very strongly to make sure that where we can, we involve the wider community. And it really is a challenge for us, because that means just at the time we get our arms around something, we're told, that's great, go somewhere else, do something new.
There would be no better example of doing something new than the 4th of July landing on Mars in 1997.
Spacecraft should have passed the 600 mark. Airbag should be inflated.
Pathfinder's airbag touchdown was as unconventional as it was daring.
I believe I have a firm signal.
And after bouncing to a halt and unfolding, a tiny rover had trundled off the lander. The first wheels ever to roll on Mars.
Well, it's my distinct pleasure to present to you the first rover on the surface of Mars.
The combination of an airbag landing, the tiny rover, and emoting engineers and scientists made for something very different than the typical NASA mission.
Yeah, opening a new era of exploration, as in the framework of the faster, better, cheaper, actually starts tonight.
Pathfinder captured the hearts of people everywhere, and the mission quickly became the poster child for faster, better, cheaper's most forceful proponent, NASA Administrator Dan Golden. His ambition was to darken the skies with inexpensive but innovative spacecraft, and should a few of them occasionally fail, that, he had declared, was an acceptable risk.
I think all the elements are right here at JPL, and I think if you have confidence in yourselves to go to the cutting edge and not be afraid of failure, just don't be afraid, I think great things will happen.
Golden's pronouncements were always forceful, but they could also be contradictory.
It was such an exciting mission. It was the first mission in the whole series of Faster, Better, Cheaper. I really wanted that to come through. So I thought it would be okay to tell them don't fail. And I have to admit I did that. But I wanted to see where the breaking point was.
Risk-taking was one Golden message. There was a second one: what the consequences would be for not delivering missions on time and on budget.
So he would come out and berate us for the old NASA policies and practices.
Our record of overrun is beyond belief. Our record of not delivering on our promises is very open. And there's a sense if all we have to do is get it working and launch it, all is forgiven. Hopeless. That will never occur again. And we'll cancel the sick chickens. And we'll prioritize. Darwin is going to reign supreme at NASA of the future.
And then he would jump up and down with joy at the liberties we were taking.
Remember, question authority. You've got to do it. And if you're afraid, you don't belong here. And if we at headquarters or anyone forces a contract down your throat that's stupid, how do they say it? Just say no? I'm serious about that. You better not take it, then take it, and then when a problem occurs, say, I have an excuse. No excuses are accepted. Don't take shortcuts. And if you got a problem, say it, and if you overrun more than 15%, we cancel it. I want you to be sure you understand the rules. This is how Darwin works.
This was very tense. He would come here and he would scream at us, quite literally scream that we were not taking risks, that we were too conservative. And, you walk away from that and you ask, I wonder if he's right. As much as you're defensive, you ask, was he right?
Pushing hard on JPL was one part of Dan Golden's plan to reinvent NASA. The Mars rock, hinting of life elsewhere, was another. For America's astronauts were seeking a new destination. Any first step would be to explore Mars with robots, and leading that effort at JPL was Donna Shirley, champion of Pathfinder's rover.
Something happened, and this is what happened. This is Allen Hills 84001, and it's had a huge impact. Whoops. I don't know why I do that. There's no orientation. And this is what they think might be a life form, except it's a couple orders of magnitude smaller than anything that's been found on the Earth. NASA decided, gee, we better start looking at what all this means for the potential Mars mission. So there was a
What NASA wanted was to send a steady stream of spacecraft to Mars. Orbiters, landers, and even missions to bring Martian rocks back to Earth. All to be done cheaply.
The Mars exploration program currently has $150 million a year. That's about the size of a major motion picture. So you can pay your $8 and go to a movie, or you can go to Mars, whichever you like.
To cope, Shirley reorganized and introduced a radical new way of conducting business. After building a spacecraft, teams would hand over the controls to a single centralized group called Mars Surveyor that would fly all of the Mars missions.
The biggest problem I had was getting the project managers to work together, because the system at JPL and almost every place is set up so that if your project works, you're king. If your project doesn't work, you're a goat. And program? What program?
The program also called for using industrial partners more often, a strategy already well underway. As JPL built Pathfinder, Lockheed Martin Space Systems in Denver assembled an orbiter, Mars Global Surveyor.
We had a great team that shared the objective that we were going to make this launch on time, and we were going to make all the requirements, and we were going to do it within the cost and schedule. The team clicked. We had a good plan. I think we didn't deviate from the plan.
The plan for cutting costs included reducing the amount of fuel needed to go into orbit at Mars by using a daring technique called aerobraking.
And that requires using the solar arrays, which are on either side of the spacecraft, to essentially drag through the atmosphere of Mars to gradually slow the orbit of the spacecraft.
Aerobraking had been tried only once before at Venus, where the atmosphere was more predictable. And it had been done as an experiment at the end of a mission, not the beginning. But these kinds of decisions were paying off in money and time.
It just almost made your head spin with how rapidly the whole process worked.
Mars Global Surveyor met its launch schedule and not only stayed on budget, but gave back to NASA $6 million.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition. And we have liftoff of NASA's Mars Global Surveyor as America begins its journey back to the Red Planet. Everything is continuing according to the timeline.
Main engine and vernier chamber pressures are good. And we have ignition. We have started the second stage engine. We have spin rocket ignition. Third stage ignition.
And we have confirmation that we have spacecraft separation. Mars Global Surveyor is the first of 9 U.S. spacecraft that will journey to Mars over the next decade.
Launch was very good. Spacecraft came off the launch vehicle, and we noticed that one of the solar arrays didn't fold out into its normal position.
Good afternoon and welcome to the Mars Global Surveyor post-launch press conference.
About that minor problem with one of the solar array panels, what is the worst case scenario? What happens if it doesn't get extended further? What are you going to try to do to fix it? If you get to Mars with it like this, do you lose anything? Do you lose power? What's the ramifications?
The fact that we had a crippled solar array wing at the very beginning of the mission, which was absolutely essential to being able to do the aerobraking, really upped the stakes on figuring out what had gone wrong with the solar array deployment and trying to find a way to get it fixed.
Telemetry suggested the array had not latched into place. For the entire cruise, the wing would slightly sway back and forth. But tests on the ground pointed to a potential fix. Once at Mars, it was possible that the pressure of aerobraking would provide the added push the panel needed to lock into place. And in early September 1997, after a journey of 300 days and nearly 500 million miles, Global Surveyor was bearing down on Mars. For orbit insertion, as with the cruise phase of the mission, assignments were split between Pasadena and Denver. Lockheed Martin handled the day-to-day monitoring and flying of the spacecraft, while JPL provided deep space communications, navigation expertise, and overall management. For project manager Glenn Cunningham, the events surrounding orbit insertion made for an especially anxious time. 4 years before, at just such a moment, his Mars Observer spacecraft had vanished without a trace.
All stations Mars Op. MGS-8, this time we should be one-way light time from the burn starts.
Could we switch back to the other plot for a minute? I want to see how far we're going because we're pretty close to coming into occultation. FOM, this is navigation on Mars Ops.
Navigation, go ahead.
Going into the occultation, we are taking a close look at a Doppler signal, so we have a Doppler signal of a minus 50 hertz. At this time in the mission, this is more than we had expected, which is a good indication that the burn is proceeding very close to nominal. Of course, we won't know until we see the other side of coming out of occultation, but right now it looks like there's a slight underburn.
We were watching the telemetry, and we had this computer visualization going along. So as the telemetry hit the ground, people were calling out, main engine on, main engine firing. And there's always that tense moment when you come out from behind the planet.
We have a signal in the SSI.
At this time, we have all 4 stations locked on the carrier. AGC levels are on negative 155 to 156.
Celebratory peanuts there. All right.
Glenn, MOI peanuts? MOI peanuts, okay. Good person, MOI.
Thank you. So we're dead on the money on that one. All other attitude control telemetry looks pretty good. I'll go through them quickly. The control of the spacecraft right now, pause errors and body rates look good. So looks like we had an excellent burn.
Go ahead, FOM.
Glenn, we've got a healthy spacecraft in Mars orbit, and we're go for aerobraking.
Roger, I copy that. Couldn't be better. So all well and good, we thought. We did a couple of drag passes, and we noticed that the panel moved a little bit. And one day, the panel moved really significantly, and we got really worried.
One of the engineers said, as far as the aerodynamics are concerned, on the last pass, it went past the point where it should have latched into place. We said, that's not physically possible unless the panel is actually broken. And he said, that's what the aerodynamics are showing. And I said, I need a new aerodynamicist. The panel was physically bending, not just not latched, but it was actually out there flopping in the wind.
there was a break in one of the hinge joints. The risk was that it would literally snap the spacecraft solar array off at that damaged point. So, gosh, this could be, mission catastrophic.
To protect the spacecraft, it was commanded up, out of the atmosphere. The move bought the engineers time, but it also created a new problem.
We knew we were actually very much racing the clock at that point. We did have another gotcha. We realized that if we didn't get restarted aerobraking, we would get to a condition where the orbit around the planet would leave us in the shadow of Mars for more than 8 or 10 hours, when the spacecraft had really only been designed to survive about a 1 to 2 hour eclipse.
And if that were to happen, the batteries would eventually cease charging, and slowly, Global Surveyor would freeze and die.
Good morning, and thank you for joining us at the Jet Propulsion Laboratory. The Mars Global Surveyor spacecraft has been in orbit around Mars for about 2 months now. Several members of the team are here this morning to give you an update on the mission.
We believe that we have identified a secondary failure in the solar array. This little model of the panel shows you the 20-degree kink, so to speak, between the yoke and the inboard panel where the damper arm was caught.
The solar panels were designed to swivel. Rotating the broken wing might reinforce the panel enough to endure the stress of aerobraking. But all of the delays had made shambles of the orbit plots that had been painstakingly calculated based on the need of science instruments to see the Martian surface in daylight.
To do the science it was designed to do needed to not only get from the big orbit, the initial capture orbit, down to the science orbit, but it needed to do it in a certain amount of time so the lighting conditions were appropriate for all the science instruments that we had on board. If the lighting wasn't right, a lot of the science instruments were not going to work.
An entirely new sunlit orbit plan had to be created on the fly. Then slowly the spacecraft was dropped back into the Martian atmosphere. The crippled solar panel held. In the days that followed came more encouraging news. Science discoveries. There were faint signs of an ancient magnetic field and images of geological features to outrival some of the most spectacular places found on Earth. But there was a price to pay in having saved the mission. Aerobraking was originally scheduled for 4 months. It would now consume a year and a half. And that meant added strains on budgets and people at a time when 2 more missions were about to fly. They too would require urgent attention. And for every day that passed on their journey to Mars, the breaking point for faster, better, cheaper drew nearer and nearer. There are many reasons for the grip Mars has on the human imagination. Its mysteries beckon in part because of what our planets have shared in common. In the distant past, Mars appears to have been much warmer, a place where water in great quantities once flowed on the surface. But where did it go, and why? Some scientists think the answers to these questions might be found in the Martian atmosphere.
All of the geologic evidence that we see on the planet from early data from Mars suggested that it was once very wet and therefore apparently warm. Well, the atmosphere role in this story is, well, where did the atmosphere go? Why is it so dry? Why is it so cold? How did the climate originally start out as wet and warm? We couldn't explain that early on, and we couldn't understand why the atmosphere changed so radically. How had the evolution of the planet got it to where it is today?
Dan McLeese devoted his science career trying to answer these questions. He worked for more than a decade for the chance to fly a science instrument on the Mars Observer mission, the spacecraft that was lost just before reaching Mars in 1993.
I knew my career and those of all of my science colleagues, some of whom I had hired to begin work at JPL on that experiment, that we were all now looking at a very uncertain future. It was going to be every man for himself trying to get your investigation flown. And now the question was, who was going to be in the lifeboat when it pushed off from the wreck?
McLeese had to wait 5 more years before his lifeboat arrived. Mars Climate Orbiter was billed as the first interplanetary weather satellite. McLeese's science instrument, built to detect water vapor and carbon dioxide, was the main payload. It was heavy, required substantial power, and was highly sensitive to heat radiating from the spacecraft. All of these factors had to be reckoned with by engineers designing the spacecraft. The result bore no resemblance to Mars Global Surveyor. Climate Orbiter's shape was asymmetrical, having only a single solar panel that was to be flown mostly off to one side. It was only one of 2 missions that were to be launched in 1998, the reason why they are sometimes jointly referred to as Mars 98. Mars Polar Lander was a throwback to the 1970s Viking missions that used rockets to reach the Martian surface. The budgets for the 2 Viking missions had been more than $1 billion. And even more astonishing from a budget perspective was that JPL and industrial partner Lockheed Martin had signed up to build and fly these 2 spacecraft for the price of Mars Global Surveyor. It's commonly believed that this 2 for the cost of 1 idea originated at NASA. But the agency's then Associate Administrator of Space Science, Wes Huntress, calls that folklore. The original proposal, he says, came from Lockheed Martin.
I was facing a decision about what to do for that flight opportunity. Are we going to do another orbiter, or are we going to do a lander? The science community was at odds as to which they wanted. Some wanted an orbiter, some wanted a lander. And at the time I thought, well, I've only got money to do really 1 mission of the cost of Mars Global Surveyor. So while worried about what decision I'm going to make, Lockheed Martin came in, said, we can do 2. I think we can do our lander and we can do the orbiter if we take advantage of certain ways in which we build our spacecraft and build them together, so we're not building one spacecraft over here and one over here. If we could do some things in construction so that we could keep the cost down and do to it. Sold.
Donna Shirley's reaction was not nearly as enthusiastic, but JPL signed on, knowing that if it didn't, some other place would.
You can see how crowded the schedule is. We're beginning to understand how hard it is to turn out production line spacecraft on this kind of timetable, especially for toughest jobs like landing on Mars.
2 missions for the cost of 1 was taking faster, better, cheaper to an entirely new level, giving pause to even gung-ho Pathfinder engineers.
I remember people bragging early on that they said, yeah, we're going to do 2 for the price of 1. I thought, good God, is that really doable?
John McNamee was picked as overall manager of the 2 missions, though he had to be talked into taking the job. McNamee started out his career in construction, but he went back to college and earned a PhD in aerospace engineering. Early on at JPL, he was seen as an up-and-comer. He had been in charge of mission design for Pathfinder and was known for his no-nonsense style and being a tough negotiator.
You can't afford to spend time with hundreds of people in rooms for hours and hours, days and days, trying to figure out what to do. You take as much data as you have, you make a decision quickly, and you move on. And you only revisit a decision if, the preponderance of the evidence says you really screwed up. We certainly made some.
To have any hopes of success, McNamee was convinced he would have to run an even leaner and meaner team than even Pathfinder had been.
John McNamee took it to an even more extreme level in the sense that the JPL fingerprints on Mars 98 were relatively light. This was, we're going to let Lockheed Martin do it the way they want to do it. And that itself was a challenge to the JPL culture, because it's like, well, what do you mean we're going to not understand what these guys are doing? And it's still got a JPL mission. Why don't we have people overseeing what they're doing? And John was very adamant about the fact that he didn't want to do that. He couldn't afford that the only way to accomplish this was to let Lockheed do it the way they wanted to.
This hands-off approach was not welcomed by a number of JPL engineers. Most were accustomed to peering over the shoulders of contractors as part of their responsibility to assure mission success. This cultural divide, born during Pathfinder, continued to widen and deepen.
I don't know that we were consciously doing it at that time, but we really were creating a separate culture, and there were two cultures. I can remember walking around one evening in building 230, I think it was. It's after hours, and most of the doors were locked, and I was looking for a paper clip or a piece of paper or a pencil, and I knocked on one door, and somebody behind the door says, "Yes," and I said, "I need a pencil or paper clip," and the voice said, "Are you a Martian?" And I said, "No," and then they opened the door. So, I mean, there was a group of people who were very, very unhappy that this divergence was taking place.
No one understood both sides of JPL's cultural divide better than John Cassani. He had been in charge of flagship missions like Voyager, Galileo, and Cassini. But he was now encouraging the lab to adapt to faster, better, cheaper. He was also serving on review boards to monitor the progress of the Mars 98 missions. Cassani saw serious engineering challenges, to be sure, but no showstoppers.
I honestly can't say that I was terribly concerned about the mission. What I didn't have a perspective of during that period of time is just how thin we were in terms of people working on the project. Most of the work was being done at Lockheed Martin. And so, say you're on a review board and you sit in the review room, you don't see what is going on.
As for make a deal and stick with it, that concept was not proving to be a two-way street as NASA began adding on unanticipated and, from the project's perspective, unwanted cargo. For the orbiter, there was only the addition of a camera. But for the lander, the requirements creep became a source of ongoing disagreements. First, a descent imager was added. Then came pressure to include a science instrument from Russia, a gesture meant to encourage cooperation with a former Cold War foe. That was followed by lobbying for a stowaway inside the Russian instrument, a microphone to listen to the sounds of Mars. The biggest battle was over two other hitchhikers, a pair of basketball-sized penetrators that NASA viewed as a new technology demonstration. They were to be released just before the lander's entry into the Martian atmosphere. Then they would free-fall all the way to the surface, hitting the ground with a force equal to 60,000 Gs. If still in one piece, the probes would search for traces of water ice and serve as precursors to one day scattering other miniature monitors all across Mars. This experiment, named Deep Space 2, was also assigned to JPL. Chosen to lead the effort was Sarah Gavitt.
There are a lot of challenges in designing a system that will survive a crash landing. We started off very early on the mission with a very aggressive test program. To truly have tested it, we probably would have needed 1,000 probes that you fired in under a variety of environmental conditions. We didn't have the luxury of doing that. And so we did have to take some shortcuts in the testing area.
Deep Space 2's breakneck schedule demanded making decisions about risks that no ordinary mission would contemplate. And when this experiment was elevated to project status, expectations for success were raised too.
John McNamee did not want the Deep Space 2 probes on his spacecraft, and I don't blame him. We were just going to make his mission heavier and a little bit more complicated.
McNamee was unable to keep Deep Space 2 or most of the other add-on payloads off the lander. And a year from launch, he saw an even greater threat looming. This one from inside JPL. The centralized team that was to fly the two spacecraft were still busy finishing aerobraking for Global Surveyor. Where, McNamee asked, was a detailed schedule for the new Mars missions? When would staff have the time to learn to operate the two spacecraft? As for the suggestion of delaying training until time of launch, that, McNamee declared, was a fatally flawed idea.
And it was just this continual, what I call the death of 1,000 cuts. And I just realized that really bad things were going to happen, and I was watching people suffer. The program was out of control. There was no way to fix it. No one would listen. I was so concerned about it that I actually retired. I just couldn't stand it. And people were killing themselves. They were absolutely killing themselves trying to make this work. And so the day I made the decision to leave was pretty much the nadir of working at JPL, which is very sad because you hate to go out on that note. But we had a great retirement party, so it worked out.
Besides official proclamations of a job well done, Shirley's retirement party featured humorous skits in keeping with the JPL tradition of its day. Then, as part of letting go, Shirley began passing away items from her office.
Yeah, we can do that. Is Dan McLeese around? Okay, Dan. Now, Dan asked me for this, and nobody wants to own Mars more than Dan.
Shirley's final gift was a not-so-subtle dig at those she believed still were not heeding her warnings.
It's a copy of the book that's only published on the internet. It's called Managing Creativity, and I modified the title to Managing Creativity, a Practical Guide to Inventing, Developing, and Producing Innovative Products, or A Prophet is Without Honor in Her Own Country.
There we go. That's the one. Great. Thank you. What can I say? Hey, how you doing?
3 months later, Mars Climate Orbiter was being readied for launch, with Mars Polar Lander scheduled right behind. A list of problems continued all the way onto the pad. Some software had to be loaded at the last minute without being put through the full rigors of testing. It was a risk the project was willing to take, as the alternative was to delay the mission by 2 years.
John, ready to go? See, Chief, got some good win.
A review board of hard-nosed veterans also delivered the verdict that the two missions were ready to fly. The JPL Lockheed team had done what many thought impossible. They had built two spacecraft for the price of one and delivered them on time and on budget.
For me personally, 15 years ago, I was hammering nails in 100-degree heat on the roof in Texas, so I'm very excited to be doing what I'm doing right now as opposed to that.
Frank, about Aviation Week, kind of a broader question on the lower cost missions. Are you guys going to maybe go back and do an operational scrub of any sort beyond what you would anyway?
I do not think spending huge amounts of money necessarily guarantees success, and we have examples of that. And I think the thing to remember is that the complex nature of this business sometimes does come back and get you with little problems. And I've said this before, the surprising thing is not that we have scares or problems. The surprising thing is that we have so few of them. It's a very difficult business.
RCO, report ready to go for launch.
Ready to go for launch.
And we have liftoff of NASA's Mars Climate Orbiter as we continue to explore the mysteries of the red planet.
We have liftoff of the Delta II rocket carrying the Mars Polar Lander, NASA's first visit to the red planet's southern pole.
View from the second stage of the Boeing Delta II vehicle.
There's the rain cloud we're flying through. Yeah. Oh, is that beautiful?
Pass through Mach 1 coming up on max Q. Main engine both burn gears continue to burn well.
We expect to see these boosters burn out and jettison. We have jettison of the solids. Again, a beautiful view from the second stage of the Delta vehicle. And we have main engine cut off.
Main engine has cut off.
The progress of launch, everything continues to go right on schedule. No issues or concerns are being addressed at this time.
Months after the launch of the two Mars 98 missions, an elated Ed Stone presided over JPL's annual State of the Lab address.
Well, it's hard for me to imagine a more exciting time than the era we're in right now. 6 launches in 6 months. Never before in the laboratory's history. It is great. It's great. Well, not only are these wonderful missions, but...
For nearly a decade, Stone had worked tirelessly to adjust the culture of JPL, to transform the nature of the lab's missions, and to fundamentally alter how the staff performed its work. And now all of that effort was coming to a head.
I've been working at JPL on a part-time basis at least since 1972, starting with Voyager. And I can't remember a time that's more exciting than this one. I really, literally cannot. Even though the Voyager encounters were wonderful, they were spikes. What we have now is a continuum.
But just 2 days after his address, one of those 6 missions, a space telescope built by a university partner, failed. An event set in motion when its cover ejected prematurely. The 2 new missions on their way to Mars were struggling too. Both were experiencing problems related to sunlight conditions, the result of design flaws. The solutions required flying the spacecraft in different orientations than originally planned.
Oh my gosh, it just seemed like it was another one of those periods where one thing after another went wrong. I mean, every day we struggled. We ended up essentially putting the MCO in a semi-comatose state so we could get through the launch of Mars Polar Lander and get it going okay. And then we said, okay, then we'll come back and we'll deal with the issues that we had on MCO. Mars Polar Lander had its own issues shortly after launch, and so we coped with that. The spring and summer of 1999 was like the most intense period of my entire life. And I later realized that was only the beginning.
The journey to a planet is usually considered the quiet time of a mission, but that was not the case for Mars Climate Orbiter due to its shape. With the solar panels swung to one side, radiation pressure from the sun was causing the spacecraft to slightly rotate.
It's actually feeling the solar wind, the solar radiation pressure, and that's kind of blowing it off course, a little bit like a sailboat off to the side. And you have to know that, but of course there's no good way to know that. You have to guess what the reflectivity is of the foil and how much area is shadowed, exactly what's going on there.
To correct for unwanted motion, small gyroscopes called reaction wheels were spun up. But eventually they began spinning too fast. Then yet another force in the form of thrusters were used to desaturate or de-spin the reaction wheels.
And you have to know, how long did it fire its thrusters and how much force was applied. And a mistake in any of those means you could be kilometers off course, because those things build up over hours, days, weeks, and months on the way to Mars. And you can actually get quite far off course if you don't know exactly what's happening.
Climate Orbiter's thrusters had to be fired every 17 hours, an unanticipated chore that added more pressure on a team that had been stripped down to a skeleton crew. Only one full-time navigator was assigned to the mission. And during the first 4 months of cruise, navigation data from the spacecraft was not even usable because of a software error. When that problem was fixed, something seemed slightly amiss in the predicted plots.
We knew there were some funny things going on with the navigation products. It was in that gray area between it. It wasn't bad to the point of you have to do something about this now or the mission's over. It wasn't just fine. And so often, when there are one problem after another, I found in my own role, you really have to judiciously prioritize.
The navigator and his supervisor expressed their puzzlement in phone calls, emails, and even face-to-face meetings. But a formal report was never submitted, and the source of the small discrepancies was never tracked down.
I think we failed to properly record it as an incident surprise anomaly. That was probably the devastating step, because it was an issue that was recognized. I remember talking about it in the staff meeting. The trajectory wasn't performing as was expected, and I just don't know why we never entered it into the system the right way.
Over time, these navigation worries came to be viewed as something of a theoretical irritant. For while the course plotting of a spacecraft can rightly be called rocket science, it is surprisingly not an exact science.
And of course, there's no GPS out there. There's really no way to know where you are except tracking with the big Deep Space Network antennas. But that's only in the line between you and me. So it's only one component of the 3 dimensions that the spacecraft is in. And so by measuring only one component, you sort of have to unfold through understanding orbital mechanics and understanding what the spacecraft is doing, exactly where it is. And it turns out that's a pretty complicated process.
So in a sense, you're trying to figure out where this thing is in this cloud out here, and all you can do is know, well, it's right here. But it could be right here and going this fast, or it could be right here and going this fast. You don't know the this way, right? The this way you only can do by building up over time. Well, it was here, and then we think it was here, and you begin to eventually converge in on it. But that takes months. The thing that helps you is that it's not just randomly moving. It's in orbit around the sun, and so it has to be moving in a predictable way, except for the times in which something else is pushing on it. And the something else that's pushing on it are these little thrusters that are on the spacecraft. And those are things which are difficult to predict.
2 months before arrival at Mars rose another problem. During a trajectory course maneuver, the spacecraft's solar panels seemed to have jammed. A problem that, if not fixed, would doom the mission.
So it was, all hands on deck. We got to fix this problem now, or it's over. That was going on at the same time. The problem that eventually killed us was manifesting itself.
The solar panel snag was solved, but the solution took the better part of a month, leaving undone other scheduled work. By now, the navigators were deeply worried as predictions still weren't converging. To address their concerns, the altitude aim point was raised to over 200 kilometers. But after the maneuver was performed, new plots showed the aim point was 72 kilometers lower than expected. With tensions running high, the navigation team leader argued for yet another maneuver to push the spacecraft even higher.
People were used to the navigators, basically saying if they didn't understand where it was super precisely, it was like, well, they always have so much margin. Those guys are, they never miss anything. And when they were trying to communicate, no, really, we really don't understand where this trajectory is going. We're seeing things in the data that don't make sense to us. The message that was received was very different, I think, than the message that they were trying to communicate. And so this was another one of those cases of not knowing how close to the edge we were on this particular mission.
Given the concerns, a small subset of a review board met by telephone to consider an emergency maneuver. No navigator was invited. The outcome was to press on as planned. While the navigation solutions were worrisome, they still showed the spacecraft having twice the altitude needed to safely go into orbit. Last-minute changes, the reasoning went, might introduce new dangers. Among those on the phone call was Richard Cook.
Oddly, a lot of the senior leadership of the development project and the operations project both had navigation backgrounds, or all had navigation backgrounds. And I think that created this model that this is something that we know how to do, and that there was not, clearly proper paranoia is one of the things that we, believe in very strongly around here. I think that because of that comfort with the underlying technical problem coming from the management, there was just not enough paranoia. And instead, if anything, there was the opposite, which is you guys are too conservative, it'll be okay because it's always okay.
2 weeks before the decision not to conduct an emergency maneuver, climate orbiters saw this image of Mars. It would be the first and only one the spacecraft would ever see.
Good morning. This is Mars Climate Orbiter Mission Control of the Jet Propulsion Laboratory in Pasadena, California. JPL is an operating division of the California
JPL's live TV coverage of the orbit insertion of Climate Orbiter began in the early hours of September 23, 1999. Given the hour, there were only a handful of people in the small mission support area for what many believed would be a routine event.
The team resides and is watching all the telemetry come on in. At the Lockheed Martin Center, they do the actual commanding.
Telecom systems go. I just want to let you know the stations look like they're in lock at the appropriate level, and everything's nominal.
In charge of the JPL crew was Flight Operations Manager Sam Thurmond. John McNamee was there too. He was now working on a different mission, but he had continued to be in close touch and his opinion still mattered. Looking on from just outside the room was Glenn Cunningham. He had recently retired, but found it hard to stay away. Moving into Cunningham's role with responsibility for flight operations for all of the Mars missions was Richard Cook.
All systems continuing to report nominal as we head into MOI.
The altitude was still, in the days up to arrival, was still hanging around the 150, 160 kilometer range. And so everyone was like, yeah, it's going to be lower than we want, but still okay. There was one last update of the altitude, and that was at about probably midnight or 1 o'clock, where the data all the way up to that point was used to calculate a new idea of what the altitude was. And it dropped to 110 kilometers, which was frightening. But I think, we still felt like that was above the survival limit of the spacecraft.
Systems FOM.
FOM systems, go ahead.
Hey, can you ask Telecom to forward a predicted AGC level once we are in the burn attitude?
Will do, standby.
You could relate almost exactly the time at which we lost lock on the signal as the spacecraft went behind Mars and what altitude the closest approach was going to be.
Okay, Station 43 reports that they dropped receiver lock at 090456, and the last signal seen in the FFT was at 090502. Roger that, thank you.
We got LOS unusually early, and I looked to go mark the spot on that graph of where it had occurred to see what the flyby altitude would be, and it was almost off the page. So at that point, I remember thinking, uh-oh, we really got a problem here.
FOM. Yes, sir. Could you call me at 79134? Roger.
The loss of signal had occurred 39 seconds earlier than predicted, and that was not good news.
See what you guys can do. Okay. Thanks, Steve.
So then we had I think it was about 20 minutes we had to wait out the burn itself and then, look to reacquire it.
Attitude, this is systems.
Systems attitude. Red update is complete.
Copy, thank you.
Joining us is Dr. Dan McLeese. This is a big deal for you here. You've got one of the 2 science instruments on board the spacecraft.
Yeah, this is very exciting.
Yeah, that's right.
I was on a microphone and I was going through the sequence of events, looking at the clock, looking at the timeline, and listening to what the operations people were saying was happening on the spacecraft.
We are standing by for exit of occultation, scheduled to be at 9:26:56.
Well, we don't even know what a typical Martian year is like from the perspective of weather. And as I was talking through near the moment we would have been in orbit correctly, it was clear that something was very wrong. I didn't know what to say on live TV, so I just walked away from the microphone. I walked into the room where the telemetry was coming down from the spacecraft, and people were saying, it looks like we're going in close. Looks like we're closer than we thought we would be. And I'm saying, there's an atmosphere. This is not the moon. We are not going to make it.
Okay, waiting for acquisition of signal. Okay, let's listen in and see if we get AOS.
And everybody's going, oh, if we just can get past the entry point, we'll see if we come out the other side. And I just couldn't believe it. I couldn't believe that people were even imagining such a possibility. I knew it was over. Twice unlucky? What? This is not possible.
And we didn't reacquire him. And I remember talking with the so-called the ace, the person that talks directly with the stations. He was talking to the station operator saying, I'm not, were you seeing anything at all, any sign of the carrier wave? And it wasn't happening. And that's when I said, all right, we're going to have to get off script.
I think there are 1 or 2 possibilities. It take a while to get it worked back around. We can get a signal.
So I remember a voice in my own head saying, follow your plan. The emotional part of it became tolerable by having something to do that had been, worked out and getting to it.
Either way, there are things that it will do other than just sit there. Okay.
And I'm producing this out of our TV control room, and no one's talking on the comm lines anymore. That's gone silent, and people are starting to pick up their telephones and communicate. It's like, what's going on here? Time comes that we're supposed to reacquire the signal. There's no signal. So 5 minutes goes by, 10 minutes goes by.
This is Mars Climate Orbiter, Mission Control. Now about 14 minutes past the point we would have expected to receive signals from Mars Climate Orbiter as it reappeared from behind Mars.
David Seidel, who was doing our commentary, gets off mic and calls me and says, I don't know what's going on. What is it that I'm supposed to say? Well, I didn't know what was going on. So I jumped up and I ran as fast as I could over to the building they were in, building 264. And as I was running, I was saying, I don't have a contingency plan for this. I don't know what it is I'm going to do when I get up there. But I've got to have a decision made by the time I get off that elevator.
Okay. Yeah, I don't think we'll probably not do the live shots. But hold on that. One thing at a time, okay? Hold on. Okay. We'll get Richard in here. We need to shoot him with a camera.
I had to grab Richard Cook out of the mission support area and have him go on live to tell whatever it is that we did know. We needed to tell that right then and there to the world.
This is Mars Climate Orbiter, Mission Control at the Jet Propulsion Laboratory. Joining us now is Richard Cook, who's the Mars Surveyor Operation Projects Manager. Can you give us a quick update of what you know?
What we're working on right at the moment is the spacecraft has a number of autonomous recovery processes that it goes through when it has a fault. We believe that we are in all likelihood in the midst of one of those, so we're going to be monitoring it over the next few hours to see what happens. I think we will as soon as we find out something, we'll let everybody know. But at this point, we're still very confident that we're in orbit at Mars, and we're going to see this spacecraft signal sometime in, like I said, in the next few hours. It was about that same time when the navigators came in and said, now we've got data all the way up until the point at which it went out of communications. When they processed that data, it dropped to 60 kilometers, right, which is obviously below where we thought it was survivable. And so that's really when it hit the fan, so to speak, and where everybody began to worry that we had lost the mission.
We have a briefing this morning to give you an update on the status of Mars Climate Orbiter.
A few hours later, not long after sunrise, what had been planned as a celebratory press conference was instead the beginning of a long search for the guilty.
Robin Soriano with Florida Today. Could you tell us who is responsible for sending the navigation commands to the spacecraft?
You must have a list of potential suspects already.
This isn't the first of the smaller, faster, cheaper, better spacecraft that you've had problems with.
Covered a lot of JPL missions, and I realize you don't get the real final tracking until you get close to the planet, but I can't recall an era this large ever.
It was just a terrible, terrible experience, terrible day. And no matter what you say in that sort of moment, you're going to cause ripples, right? I mean, the team is, struggling to stay together in a sense. And so any statement about what happened other than we lost the spacecraft, you get into that feeling of the team kind of coming apart. And it was just turned into this incredibly divisive thing, which is unfortunate, obviously.
Just to follow up on that last bit, I wonder if you could just tell us literally over the next 8 hours, literally, what are you folks doing?
Right now, we have a fully staffed flight team, both here and at Lockheed Martin in Denver. We're going to essentially begin to dive into this navigation issue as soon as possible, probably as soon as we walk out of this room.
One month before the loss of Mars Climate Orbiter, a JPL-built spacecraft called Cassini had skimmed closely past the Earth with pinpoint accuracy, bound for Saturn. Cassini was the most expensive and advanced planetary spacecraft ever built, the quintessential Battlestar Galactica.
I hate that word, Battlestar Galactica, but I understand where it came from.
Tom Gavin was a veteran JPL engineer who considered Cassini as one of his and the lab's proudest achievements. In the months preceding the loss of Climate Orbiter, he had been asked to look under the hood of some of the other, faster, better, cheaper missions. What he saw, he didn't like.
Well, near as I could tell was that all the rule books had been thrown out, that there were no rules. The rules were, there are no rules. I think there's a lot in faster, better, cheaper, but it isn't being undisciplined. You know, it's okay to take risks, but understand what risk you're taking. Okay, if you don't understand what risk you're taking, then you're uncontrolled. I mean, the MCO thing should have never happened. There was no excuse. I figured this was an easy event. And about 3 o'clock in the morning, I got a phone call. You better come in. And I walked in and I ran into Cunningham and McNamee. And I remember what McNamee said, we just took a perfectly operating spacecraft and ran it into Mars. And I was shocked. How did this happen? We know how to do this.
The cause of the navigation error had to be found, and quickly. Gavin was given that job. He assembled a group of experts that included the former head of JPL's navigation section, Frank Jordan.
I never dreamed we were going to lose an orbit to a navigation problem. It totally decimated me. And Gavin said, well, you're the guy that's got to find out what happened.
That was on a Thursday morning. By Sunday night, Jordan believed he had found the answer when he compared 2 columns of numbers. The first column from Lockheed Martin showed the amount of force exerted by the spacecraft's thrusters. The second column was JPL's navigation solutions from those numbers.
And I looked at these 2 rows of numbers, and it hit me. They're all off by about the same ratio. And I thought, there's something systematic. Why should that be? And so I computed the ratio, and it was that the number at JPL was 4.5 times larger. I said, oh my God.
The 4.5 number was precisely the ratio difference between the force of thrust as measured by English and metric units. For the entire journey, the navigators had assumed the numbers supplied to them by Lockheed Martin had been in metric units, as had been specified. Unknown to them, each time the thrusters were fired, the effect had been to push the spacecraft downward 4.5 times more than their calculations. The cumulative effect doomed the spacecraft. From morning newspapers to late-night talk shows, JPL and NASA were ridiculed, for the metric confusion mistake was hardly rocket science.
There's a little bit of human nature here because, a little bit of looking at other people's misfortunes and thinking, well, there, but for the grace of God go I, and look at those smart guys, even they're dummies. When it's laid bare and it comes out to something as simple as one team using the metric system, one team using the English system, and not knowing that there's a human foible component to it that everybody gets, because we've all made mistakes like that. This is just one of those epic mistakes.
It was a difficult time because, of course, everyone looks at kind of the final cause of what happened, and that was, the unit's error in this thrusting for the angular momentum desaturations. But of course, that's the tip of a big iceberg.
Mike Watkins had been named supervisor of all of the JPL navigators only a few months before the loss of Climate Orbiter. He too was swept into the media storm that broke over the measurement mistake.
The harder thing to talk about is, what led to the design, what led to the lack of communication, what led to the lack of staffing that didn't uncover that problem and work that problem to a solution. And I think the disappointing part was, of course, you couldn't tell that story. You can't tell that story in the Tonight Show monologue. I personally see the climate orbiter failure as a failure of communication, a failure to communicate how the flight system design with the more frequent desaturations would affect navigation, a failure of the navigation team to have enough people to communicate with their peers. Oh, hey, we see something funny. What do you think about that? And also a communication failure between our operations team and the nav team. And I think that lack of deep communication is really the thing we learn to fix in future missions.
Good afternoon and welcome to NASA headquarters. The subject of today's briefing is the first report of the board investigating the failure of NASA's Mars Climate Orbiter mission and actions underway at NASA in response.
Let me say right at the start that we clearly made a serious error. Mars Climate Orbiter was on the wrong trajectory, and our checks and balances did not reveal that error.
And suddenly that NASA euphoria that had been building all that time from Pathfinder to that moment evaporated.
Our report seems to list poor training, poor communication, cockiness, and a whole bunch of other not good things.
So I know no one person is responsible, but is there someone who should take the blame, who should be reassigned or fired?
There was blood in the water, okay? It was a feeding frenzy.
The underlying tension associated with all of this, somebody described it to me as near panic at Jet Propulsion Laboratory over this whole scenario.
These were people who really knew the space business, really understood what faster, better, cheaper meant, had deep sources that were saying, this is not good, pick two, faster, better, cheaper, pick two. And we knew it. We knew it was dead in the water.
None of us want another mistake to go unchecked and unfound.
One of the most difficult challenges I had as director was the press conference following the failures. And because such press conferences tends to be focused on fixing the blame. And of course, JPL was ultimately responsible for the mission. So in that sense, the blame was fixed on us. But on the way back to the laboratory from that press conference, I realized the most important thing was to fix the problem rather than fixing the blame, so that in fact we could create a program moving forward. And so on the way home, we worked on a speech which was in fact focused on the way ahead rather than on fixing the blame.
Without a question, yesterday was the hardest day I've experienced in all my years at JPL. It was hard because of an old truth. The higher the expectation, the greater the impact of failure. The future will depend on what we collectively learn from the loss of Mars Climate Orbiter. Can we learn from our failures as well as our successes? When we fail, do we learn to fix blame on individuals, or do we learn to accept failure as a team? Do we learn that the pain we experience in losing a mission is so great that we avoid difficult challenges? Or do we learn to accept the challenges knowing that either great satisfaction or occasional disappointment awaits? My choices are to embrace the tremendous future that can be ours. But just as our past successes did not come easily, neither will the future. In the future, success will be defined not only by what we do, but how we do it. And how we do it starts today.
And then it became very apparent that we had to do everything we could to try and save the polar lander because we had just lost the easy one. That was the easy one. And then lander was coming.
This team and the spacecraft design, has been under a great deal of scrutiny. The words we're using now is they've turned over all the rocks and are now raking the gravel.
We have never been to the South Pole of Mars before, and we're not exactly sure what we're going to be going into.
This is one of the most difficult things that you can envision in the space business. It requires a very large set of mechanical activities to occur, technically initiated separations of the parachute and of the heat shield. Descent engines have to fire for about 50 seconds to slow yourself down and come to rest on the surface.
After the cause for the loss of Climate Orbiter was found, Tom Gavin and NASA led an all-out search for flaws that might doom the polar lander. They had only 2 months to dive into the intricate details of a spacecraft that had been built 1,000 miles away and was now millions of miles out of reach. This frantic scrutiny uncovered a handful of potential problems that were addressed. There was one issue that had no solution. As a cost-saving measure during the entry, descent, and landing sequence, there would be no communications from the lander. If the mission was lost, there would be no way of knowing what had happened and little or nothing to learn for future missions. This was another faster, better, cheaper departure from standard practices, a point that the mission clearly made during reviews at NASA and JPL.
Once you begin EDL, there's no RF link. That's the way it is. Nothing can be done with that. The laboratory did not understand what was going on in that project. And it operated in a very isolated mode. That was very unhealthy.
No one had greater hopes for the success of Mars' polar lander than its young science principal investigator, David Page. Page's passion for the red planet reached back to college days at Caltech, a time when he worked on the Viking missions.
In those days, Viking was old news. The data were acquired during the 70s, and I remember used to, walk down the hallways and, one sort of gruff professor would say, "Oh, Dave, you're never going to get anywhere working on Mars. It's just a bunch of old stuff, and, just don't do that. That's completely boring."
But Page persisted. He became especially interested in the Martian poles, a fascination born perhaps out of his father's adventures as a member of Admiral Richard Byrd's second expedition to the Antarctic in 1934.
You could always argue that this is the classic case of the son following the father, or at least trying to follow the father at some level, exploring the poles of another planet. So there could be a little of that mixed in, but it certainly wasn't, conscious. Let's put it that way.
Search for water under the surface. The goal of the mission is not to find water, and it won't be considered a failure if we don't. We have good reason to believe there is water below the surface. The question is how deep and in what form and how abundant it might be. Water.
Like the engineers, Page's science team had worked in a feverish, faster, better, cheaper mode, only to have the pace become even more intense after the loss of Climate Orbiter.
We had this even bigger mountain to climb, which was to get the lander together. We had, a camera system, a robotic arm. We would dig trenches. We would look inside layered terrains. And the fact that this orbiter didn't work all of a sudden meant that our plans for how we were going to operate the lander on the surface of Mars in just a couple months had to be radically altered. Everybody was under incredible stress.
And the lander had left the launch pad not knowing precisely where it was to land. 20-year-old Viking images had identified a general area, but scientists had been awaiting new and far more detailed images from Mars Global Surveyor.
In those days, when you looked at the South Polar layered terrain with Viking, you saw this beautiful, smooth area that looked like, oh my gosh, it looks like, whatever, baby skin. There's no, there's no hazards here whatsoever.
But that impression was dispelled by Global Surveyor's images. Although this topographic map of the landing area was intentionally exaggerated to highlight height differences, it was still a sobering jolt as landing day approached.
We are an hour and a quarter away from arriving on the surface of Mars with 3 spacecraft. The soft landing Mars polar lander and 2 experimental hard landing microphones.
All protection reports, all states are nominal. We have a good spacecraft. We are ready for entry.
spacecraft engineer FOM on Mars Ops.
Yes, I'd like to report that the pyrotechnic device has been fired to pressurize the propulsion system in preparation for entry.
Copy. FOM copies. Spacecraft go for entry.
You've been sitting in the room here for the last hour or so. What's your view from the inside?
Cautious confidence. We think we've done everything we can do. It's out of the engineers' hands at this point in time, and every indication is that the spacecraft is performing exactly as intended. Everything's nice and warm and ready to start the entry, descent, and landing sequence here in just a few short minutes.
You guys have to eat a lot of people.
Spacecraft engineer, attitude can confirm initialization of the absolute slew with the target entry attitude. Copy that, attitude. Prepared for slew.
FOM copies. Autopilot initialized for slew.
This is a Doppler plot. What we're seeing as the line curves downwards is the increase in the velocity of the spacecraft as it approaches Mars. The closer it gets to Mars, the more significant the gravitational pull on the spacecraft and the greater its speed. We're going to lose this information shortly as the spacecraft turns away from Earth.
In all stations MPLAs on Mars Ops, we have all stations 14, 63, and 15 all CLOS.
Very latest.
FOM, spacecraft engineer.
The FOM.
Happy landing, Sam.
Copy that, lad. 30 minutes or so to go here.
This is a view of the landing site. The red ellipse is the target area. And in the center of that ellipse is where we're headed today.
They showed me a picture of this sort of large depression. And it reminded me of Climate Orbiter again, that somehow the lander had sort of drifted off course a little bit compared to where we wanted to land it, and that it was not going to hit this cliff, but it seemed like it was awfully close to this cliff feature here. And I said, oh God, how did this happen? And, somebody said some sort of techno mumbo jumbo about, trajectories and solutions and all this kind of stuff. And I said, okay, whatever. But I think that was the real interesting moment for me, because it really hit home sort of how remote Mars is from the Earth. You're just completely on your own. Like the concept of true exploration really hit home, that yeah, we were really, really out there.
This time, the lander should be commanding separation from the back shell with the guidance system initiating a pitch-up maneuver. Power descent is only about 40 seconds in duration. During that time, the spacecraft will decelerate from approximately 75 meters per second, or 160 miles per hour, down to a soft landing at just over 5 miles per hour.
Systems, we expect touchdown at 201445.
Copy that. I believe, are we past that mark, systems?
Affirmative.
Copy that. At this point, the lander should be resting safely on the surface for the nominal flight path. Begin storing MARDI data and critical entry, descent, landing, engineering telemetry in its non-volatile memory.
Just minutes after the time of the scheduled touchdown, into the mission support area walked, unannounced, NASA Administrator Dan Golden. He was followed by JPL Director Ed Stone and Caltech President David Baltimore. And on the telephone from Washington was Vice President Al Gore, waiting to congratulate the team.
In this particular instance, it was almost like, you hear stories about animals or cats, that are pregnant cats that want to go off in the corner and hide somewhere before they give birth, right? This was definitely one of those cases where it was like, can we just get all of the press out of here and get all of the dignitaries out of here and let us do what we need to do, in dignity by ourselves, and we'll call you, get the dad out of the delivery room, go to the bar across the street, and once the delivery's done, one way or the other, we'll call you when this is over.
we were showing him the pictures of the landing site, and he looked and said, "God, are you sure this is a safe spot?" You know, all of a sudden, you could see this, twinge of doubt sort of, roll over the man's face as he started, sort of looking at what we were actually going to do here, which was to, come blazing through the atmosphere, open up all these parachutes, put on these thrusters, and try to land this three-legged lander, in this terrain here.
All stations and field lights, we're still looking and expecting close out. The signal, the notes will not quite be as soon as they hear from any of the spectrum analyzers. Stay by.
high noon was the first opportunity to hear from the lander, but there was only silence.
Imagine standing next to Dan Golden, and Dan Golden's assistant's got the telephone tied into Gore to report the success, and that's bad news, bad day.
We did not hear. But we had a plan for what would happen when we didn't hear.
We have a plan of additional communications opportunities today.
That playbook, I think it reflects our normal model, which is, well, it's a problem, but this thing will, this is what could have caused it, and that will be okay because there'll be another opportunity.
What are the possibilities, realistically, that something catastrophic has happened to the spacecraft?
I think we have a long way to go before we're going to begin to get concerned.
Can you think of a single scenario that would account for the failure of communication with both the probes and the lander?
Not separating, the cruise stage not separating.
And so we played through the playbook, which stretched for days.
And we will continue to look for the probes once a day all the way out through Sol 9. But to be honest with you, the chances of hearing from them will be greatly decreased by tomorrow morning. It was a very bad time period for those of us who had given so much and invested so much in a mission. You get very attached to these spacecraft. And when you lose one, it's like losing a best friend, and it's very difficult.
How confident are you that the probe is intact on the surface?
I think that that's the big question.
And it begs the question again whether we're trying to do these too fast and too cheap. And that is something that we hear quite often from people around here. What do you say?
Frankly, are you not clutching at straws? We haven't exhausted all the possibilities.
I do think that the lesson I learned from that is that they either go really well or they really don't go well. There's not really a in-between that's very likely.
We're pretty much reaching the point where we've used up our final silver bullets.
You can still continue to try to find it, but to get yourself in that mindset, which you got to accept it, is a better for everyone than the sort of slowly ripping the Band-Aid off, which is what we did.
JFOM, go ahead.
Yeah, Sam, I'm sorry to report that all we have is HKTM at this point. It seemed to have been a nominal no-contact MR pass.
Copy that, Mark. Thanks for that. Thanks for hanging in there with us.
The loss of Mars' polar lander was first believed to have been caused by a premature shutdown of the descent engines. If true, the lander, after safely traveling 200 million miles, was lost in the last 200 feet of its journey. But no crash site has ever been seen from orbit. Subsequent research points to the likelihood that the lander and its cruise stage never separated. But Mars' polar lander remains a mystery still to be solved.
We just went too far in trying to skinny down and reduce the number of eyes, the number of people involved, was just too fragile. It almost worked. In fact, it probably could have worked. But that is not the right answer. The right answer is to find the right balance of checks and balances and safety net so that, in fact, you don't expose teams to these sorts of situations, which are really devastating for the teams.
The eyes of the world are always upon us when we go to the Red Planet. When we succeed,
1 week after the failed landing, Ed Stone once again addressed the lab. While acknowledging another painful loss, his message was really about the future.
The last week has been very difficult, and the attention is far from over. But scrutiny and criticism can be good things. At times, we will be uncomfortable with some of what is said about us. But at the end of the day, we will learn from what has happened, and JPL will be a better place for all of it. I was reminded of this earlier this week when Homer Hickam, the author of Rocket Boys, some of you may know the book by the movie title October Sky, and he suggested that I turn to chapter 19 of his book. A lot has happened to you, probably more than I know, but I'm telling you, if you stop working on your rockets now, you will regret it the rest of your life. You've got to put all your hurt and anger aside so that you can do your job. Your job, Sonny, is to build your rockets. You've got to give it everything you've got. You all are Homer Hickams. A lot has happened to you, probably more than I know. But if you stop working on your rockets, on your projects, you too will regret it the rest of your life. You have to put all your hurt, your anger aside so you can do your job, because your job is to build the rocket. Your rocket is going to open the doors to space exploration in the 21st century. Thank you.
All members' opening statements will be placed into the record at this point. Will you all please stand and raise your right hand?
We just went too far. We pushed those boundaries too far, and we cut back too far on what history has taught us to be sound management and sound engineering principles. And
I think the project felt that what they were doing was reasonable, and that it could work, and it would work, and it could have worked, and it would have worked if nobody made a mistake. But that's the big if, and that's what people are. They're mistake makers, and you have to have a system that's tolerant to a mistake, which means you have to have checks and balances.
We found a NASA headquarters Jet Propulsion Laboratory interface that was ineffective in resolving issues and managing risk. We found a Lockheed...
I think that JPL had two responsibilities. They had the responsibility to follow direction, but they also had the responsibility to go back and to say, that it wasn't, that the direction was not executable.
And we identified organizational changes that we thought were appropriate at JPL and at NASA headquarters to assure the success of the program in the future.
I was excoriated in the hearings in the Congress. It was ugly.
I don't object to losses from taking risks. That's what it's all about. I definitely object to losses due to mistakes, especially what I unmercifully will call stupid mistakes.
I'll answer the question. I feel a certain level of hostility in this interaction.
Well, you're a good politician. I'm trying to get to the point. Yeah.
But those 2 missions to Mars will always be on my back
I don't care. We wanted to push the limits to see how far we could go.
He was not thrilled with what he heard, I guess would be the way to describe it. I mean, he didn't say anything about you're wrong. It's a problem, but he was having difficulty, as I would have, internalizing the whole activity.
You don't win popularity contests when you're changing a bureaucracy.
Now, as a NASA administrator, I had to take the heat. I was worried we were going to lose the Jet Propulsion Lab due to this gnashing of teeth. And there were people at NASA headquarters who loved retribution.
It had to go down hard, and I think it would have gone down hard with anybody, because it was a pretty hard-hitting report, and it really said that, we were on a course that was destructive for NASA.
So if there is no further business before the Committee on Science stands adjourned.
I pushed too hard. And in doing so, stretched the system too thin. It wasn't intentional, it wasn't malicious. I believed in the vision, but it may have made some failure inevitable. I have no qualms about pushing them, albeit they should have pushed back a little bit, but it's okay. I wanted to demonstrate to the world that we could do things much better than anyone else, and you delivered. What we did is we reduced the price of the mission from in excess of billions to a few $100 million. We knew we could have errors, and it occurred. So what? So what? I salute the team's conviction and courage, and make no mistake, they need not apologize to anyone. They did not fail alone. As the head of NASA, I accept the responsibility. You can't have stunning science without failure. And I have no regrets about that mission. Zero, none.
The Mars 98 failures were a setback and a new beginning. Rather than retrenching, NASA's Mars program was reinvented and given greater financial support. In years to come, technical twins of Mars Polar Lander would fly. The Climate Orbiter mission was immediately reflown as Mars Odyssey 2001.
We have basically 8 receivers in lock right now on the spacecraft. All
Dan McLeese's science instrument on his third attempt finally made it safely to the Red Planet. Getting Mars Odyssey underway was a fitting capstone for Ed Stone's tenure as JPL director. And before departing, he signed on to a bold plan to send an entirely new kind of rover to Mars. Dan Golden liked the idea so much that he ordered up 2 of them. It was one of his last major decisions. As 2001 was also Golden's final year at NASA, the era of faster, better, cheaper came to an end. But there would also be far fewer Battlestar Galacticas. And while one era was ending, another was beginning. For JPL and its new director, Charles Elachi, the arrival of the 21st century would be the opening of a renaissance of space exploration. And several of those involved in Mars 98 would join the ranks of the laboratory's upper management. One of them was Tom Gavin, who would put in place flight rules and practices that all missions were required to follow. Spacecraft became more expensive as a result, but more of them worked. The year 2001 also marked the completion of Mars Global Surveyor's primary mission. The mapping orbiter would continue to operate for 5 more years, collecting more data than all previous Mars missions combined. But Global Surveyor ceased operating in 2006, its demise brought on by an error made during an update to the spacecraft's complex computer system. It was another reminder that humans are, and will always be, mistake makers.